Hi guys, welcome to Basic Bit. Today is December 4th and it's Friday, and we're going to be working on the kth factor of n. So given two positive integers, n and k, we want to consider all of the factors of n sorted in ascending order. And we want to return the kth value in this list if it exists. And if the list has less than k factors, we return -1. Let's code out the brute force solution. So first, we're going to want to generate all of the factors less than or equal to n. So we can create an empty list, and then we can iterate through all of the values from 1 to n inclusively. So we're going to do n plus 1, and we're going to check to see if it can be divided into n. So n divided by I should have a remainder equal to 0 if I is going to be a factor. So if it's equal to 0, list.append I, and then we're going to check the length of the list. If it's less than k, that means we can't get a kth element. So return -1, else we can return the kth element, which in this case would be at index k minus 1, because if we wanted the first element, let's say k was equal to 1, we want the first element, that would be index 0. So that's why we have the -1 in there. Now let's run our code. The results look good. I think we can submit. And the solution was accepted. Now let's take a look at the runtime of this brute force solution. To demonstrate the running time would be to look at a specific example. So here, let's say we're given n equals 10 and some k value less than n. So all the potential factors of n are listed here, from 1 to 10 inclusively. So in our algorithm where we have a for loop and we go through this list, and at each value we're checking to see if n divided by this value leaves a remainder of 0. So 10 divided by 1 leaves a remainder of 0. 10 divided by 2 also leaves a remainder of 0. And out of this list, also we have 5 as another factor and 10 as the last factor. As long as k is less than or equal to 4, then one of these factors will be returned, because our list of factors will be 1, 2, 5, and 10. So the running time of this algorithm is O of n, because we're required to check n values. So brute force is really not too bad because we're getting linear performance. Brute force performance is really not bad because you're getting linear performance, but we can optimize this further. You can see from this example another property of these factors. They're paired up. So 2 is paired up with 5 and 1 is paired up with 1. And there's a divide between the two types of factors. And that dividing line is actually square root of n. So we have factors less than the square root of n and factors greater than the square root of n. We can optimize our performance to run in O of square root of n. Essentially what we would do is we would iterate through this list, but only going up to square root of n. Then that would get us the factors 1 and 2. And then once we hit square root of n, we're gonna go backwards. And we're gonna use a neat trick where we only have to store the elements, the factors that are less than square root of n, and then By going backwards, we can use 2 to generate 5, and then we can use 1 to generate 10.